As Don said, my name is Jeff Bonkowski. I'm a retired career firefighter with over 30 years in the fire service. Through my career in the fire service, I did a lot of training with hazardous materials and trained to the level of a hazmat specialist. I was a paramedic and also did some work to become a tox medic, learning about hazardous chemicals and how to treat people with exposure to those. And after retiring, I wanted to share my knowledge of what I learned over the course of my career in hoping to make firefighting a safer profession. And when I started my retirement in doing consulting work, I was doing it with the ethanol industry because ethanol was becoming a commodity that was shipped by rail in large quantities. And when I would go to many of these ethanol plants that are in rural areas where there's, limited water, limited foam supplies and things like that, chiefs would ask me, how I would deal with an incident if I was in charge. And my response to them was always, I would let it burn, protect exposures, because you don't have the resources. So based upon having to tell chiefs that, I thought, being the 21st century, there has to be something that can make these types of fires more manageable and safer for firefighters when they would be called upon. And so I started my quest to find a solution, and that led me to hazard control technologies and what we're going to be talking about today, encapsulator agent. So I hope to, through this presentation and sharing with you, give you some ideas and give you some more knowledge of how this agent works and how it can be beneficial when we come to the petroleum industry. In our mission, it is to make the world a safer place. We are a global distribution company, so we do have a network that covers many parts of the world. We're based out of Atlanta area, Fayetteville, Georgia. The company's been around since 1997, so this is not a new product that has just come to market. And we're going to talk about some of the benefits that this agent brings in many different areas, and why I was drawn to the product and why I'm now working for Hazard Controls. So we're going to key in on the petrochemical, the hazards, and talk about the solutions. In here I show the fire suppression and the vapor control. That's one of the things I like to key on when I do my presentations, especially with firefighters, because we're used to using water and we're used to using foam. And I always throw the question out to the firefighters, what do you have that works on vapors? And I usually would leave them a few seconds to answer the question, and I usually end up with a bunch of blank stares because they have nothing. So we're going to talk about how the encapsulator agent is beneficial in being able to control those vapors. We'll talk about the spill control, the tank degassing and tank cleaning. That can also be cause some issues and problems, be time consuming. And we'll see how using an encapsulator agent can speed things up. So I get into and asking the question, is your team prepared? Are you ready for not only the emergencies, but just everyday issues that might occur when you're dealing with these types of situations or these types of emergencies at different facilities? And the big one is going to be when you're faced with an emergency, water supply. Have you addressed the need, or have you addressed the issues or the problems that might occur if you have a major incident at your facility and you need large quantities of water? How are you going to get the water to your facility to be able to deal with that emergency? So water supply is a huge issue, and was one that I dealt with when I was working with the ethanol industry and those refineries and those different facilities. Water supply was a huge issue because many of them are working off of wells. So they're very limited on the amount of water that they can supply and deal with. And then we have to look at the environmental and the health issues. We know with current technology that we're using with the fluorinated foams, it's a huge health issue because of the fact that we're dealing with forever chemicals, that PFAS. And we know that when it gets into our aquifers, our drinking water, it stays there forever and it bioaccumulates in our body. So it's bad for the environment and bad for the health, and it's why it's being banned around the world because of the problems it's causing. So as we sit there and we look at all that and we start looking for a solution, I hope to, when we talk about the encapsulator agent, talk about how we can have one agent that can handle many of the problems that we're dealing with and not have to look at multiple extinguishing agents. Here it is, one agent, multiple hazards, and being able to deal with them. So the objectives, I hope, give you a little bit of a better understanding between the differences between foam and encapsulator agent. How with foams, we're working on a mechanical basis, creating bubbles, which causes separation between the fuel and the oxygen. And the encapsulators, how they work on a chemical molecular basis, changing the makeup of a water droplet, and how that then is able to cool, how it's able to extinguish, encapsulate, and just all the benefits it brings. And again, able to deal with the multiple hazards. Talk about the applications, the rates, and how it's different than your foam applications. And then identify the hazards and emergencies where the encapsulator agents can be used. When we look at in talking in the petroleum industry, they talk about the upstream, the midstream, and the downstream. Here we have all of these different areas in the petroleum industry that we can be beneficial and being able to assist, from the oil rigs where they've got, again, I'm going to mention those flammable vapors and the liquids, the H2S gas and other gases that might be there, and acids, as well as confined space and cleaning that needs to be done to keep those areas safe for the employees and the workers. When we get into refineries, again, those flammable vapors in the news. I mean, how many times do we read or do we see on the news where there's been a incident at a refinery where there's been an explosion and a large fire? Let's see how we can address those and how we might be able to help prevent some of those. The flammable liquids, we have a pipeline, we have something burst and start to cause a large spill or even a small spill, which can be a hazard. Again, we're dealing with the H2S, the acids. And, when we talk about the confined space cleaning, we'll see as I continue on, starting to get into that tank cleaning and tank degassing at the refineries, things that need to be done. And again, then we start getting into the pipeline, getting it from, those oil rigs to the refineries, and then from the refineries to your tank farms, where it then goes on to tanker trucks to be distributed to the fuel stations. And, when we sit there and start looking at the tank trucks, they again start getting into different hazards because now we're dealing with mixed fuels. We're dealing with the diesel fuel. We're dealing with, maybe straight gasoline, or we could end up with E85. So there's a large range of hazards, going from a combustible to a flammable, dealing with a petroleum, a hydrocarbon to an alcohol, so a polar solvent. So there's multiple hazards when we start looking at these tank trucks. And, then we start worrying about the roadside collisions, those tank truck rollovers. And we have to talk about and think about that cleaning, being able to clean those tanks when we start, changing out what might be in them. And we get to the fuel stations where now we have to still worry about those vapors, when they're taking from the tank truck and filling the underground or above ground storage tanks, because there are some stations in at least in my area. I'm Arkansas, up in the mountains, so not all areas are able to get the tanks underground. So we have some areas where fuel stations have above ground storage tanks. And again, dealing with those mixed fuels, in incidents with fuel spills, people overfilling their gas tanks and having small spills, or we've even had stories where tank trucks are overfilling and you now end up with a large spill on the ground around those tank trucks. So we have to also worry about those leaking storage tanks that are underground, causing incidents in the ground around them into sewer systems. Like I say, I was in a community when I was in the fire service where, they had a facility where gasoline was getting into the groundwater. We ended up into a dry season, a little bit of a drought, and because of that, the groundwater's kind of settled and dropped the levels of the groundwater dropped down, got down to a point where the water and the gasoline that was leaching into the soil made it into the storm sewers, this drain sewers, and it blew up basically a pump house for the storm sewers. So the hazards that these leaking tanks can cause can be a huge impact on communities. So we're going to get in and talk about how encapsulator agents can address all of these different hazards, and to give you the best understanding of how we're able to address that, we first need to help you understand what an encapsulator agent is and how it's basically entered into the water. And when we talk about it, as I said earlier, when we talk about foams, we're talking about thin wall bubble structures. We're calling about creating a bubble, a blanket, working on two-dimensional fires, creating that blanket. When we talk about the encapsulator agent, you're going to hear me talking a lot about spherical micelles. That is going to be the basic building block of an encapsulator agent. And we'll talk about how it's able to work on those hydrocarbons, those carbon molecules, as well as the polar solvents, the alcohols, and being able to encapsulate not only the liquids, but also the vapors, which is a huge, huge advantage over most of the agents that we have available to us, because up until encapsulator agents, there has been nothing. That's why we have, so many explosions at some of our refineries, because there's no way up until now that they're aware of to be able to activate a suppression system that can encapsulate the vapors and mitigate the hazards before an explosion or fire occurs. So as I said earlier, we'll see how encapsulator agents going to work on that chemical molecular basis. Excuse me. To help you understand, I want to show a real quick animation of how these spherical micelles form. Again, it's the basic building block of the encapsulator agents, but it forms with our molecule. Our molecule is very simple. It's got a polar head. The polar head loves water, wants everything to do to be in water, and then a nonpolar tail, which fears water and wants to get away from the water. So when we start to introduce this, and it can be batch mixed, it can be inducted as it's shown, when the concentrate enters into the water, because those tails want to get out of the water, it instantaneously mixes and creates and forms these spherical micelles, which then flow through the water. When it comes out of the sprinkler head or the nozzle, whichever devices you're using for application, those spherical micelles closest to the surface, because it takes less energy for those molecules, for those tails to break apart and spin out than it does to stay into those spherical micelle formations. They break out and tails stick out, and they put a skin on the surface of each and every water droplet. Yet inside of each of those water droplets, there are still millions and millions and millions of spherical micelles. So that's how we're chemically changing the makeup of a water droplet, and now how it works. When we continue on and talking about the encapsulator agent, we do have an NFPA standard that we fall under. It's the NFPA 18A standard, which is a standard for water additives for fire control, and again, that word, vapor mitigation. Okay, so it's right here in the standard that these agents are able to control those vapors. And in there is section 7.7, which is the spherical micelle stability test. So right here, it even makes certain that an agent that falls into this category and is able to pass this test is going to be able to have those properties of being able to deal with those flammable vapors as well as the liquids, rendering them non-flammable, non-ignitable, non-explosive. So it changes the way we're able to deal with some of these high hazard emergencies that up until now, until we've learned about this product, we haven't had the ability to deal with. So here, it's been around since 1997. It's just that it needs, and we need to get that education out to people so they have a better understanding of how it works. So as I said earlier, when we sit there and we start talking about the abilities of the encapsulator agent to encapsulate those fuels, Being able to encapsulate them so that there's no longer flammable, no longer ignitable, reducing the risk that they pose. When we talk about other types of materials, we offer this burn back resistance that it changes, because when we talk about foams, again, foams have that burn back resistance where, it's only good for a certain period of time, bubbles break down, we need to do the reapplication. When we talk about the encapsulator agents and encapsulating those fuels inside of those water droplets, okay, now we've changed that to where it's stable. We can take a torch, once we've encapsulated the fuel, and pass a torch across or evaporate it off with the torch, the solution off with the torch. And through that process, we will not have a fire, or we will not have flames redevelop. Once we've encapsulated the fuel, it's no longer a hazard. When we look at that change we put and made to the water droplets, those tails that are on the surface of each and every water droplet, they change the mechanism of being able to cool. Okay, so we can take temperatures that are in excess of 1300 degrees and drop them down to about 120 degrees in a matter of seconds. And through that process, there is no scalding steam. So we're using those tails that are on the surface of the water droplet. Those tails on the surface, they act almost like a heat sink. They drive the heat inside of the droplet. The water that's inside, or I should say the spherical micelles that are inside, they rapidly absorb the heat faster than the water that's in there. And once those spherical micelles inside the droplet rapidly absorb this heat, they slowly release into the water around them. And in that process, the water never hits 212 degrees. So that's why there is no steam that's generated when we are using this to be able to extinguish and cool fires. Again, the advantage is with a water droplet, water droplets about 3 to 5% effective at being able to cool. And when we start adding F500 into the water stream, we're giving more surface area because of that change of the way that cooling is working with that micelles being able to send the heat into the water droplet. So we're now using about 95% of the water droplet to be able to cool and extinguish. So we're using a lot less water to be able to put fires out and being able to deal with these some of these emergencies. The other advantage is when we're dealing with, again, refineries, we're dealing with, even our tank trucks that might roll over and catch on fire. One of our sources of reignition is the hot steel, the hot metals. So if we can cool that steel down below that auto ignition temperature, we've just eliminated that source of reignition for the fuels. We talk about the free radical interruptions right now, the carbons, the unburnt fuels, and the black smoke. Again, we talk about the ability of the agent to encapsulate those like hydrocarbon molecules and things like that. So we're able to encapsulate, have an effect, get in there, eliminate and reduce those fuels and kind of attach to them. And by doing so, we're able to reduce the carcinogens and the soot and toxins that are in that black smoke. And by doing that, we're reducing the hazards that are heading downwind, not only for the firefighters, but for the community. So when we look at the fire tetrahedron, we understand, from day one in the fire service, when we go to training, that if we have an effect on any parts of the tetrahedron, especially the 3 legs, we've extinguished the fire. So if we are able to reduce the heat, encapsulate the fuel, or get rid of the fuel, there can't be a fire. With foam, creating that blanket, causing the separation, it's doing nothing to remove the heat or the fuel. So that's why we need to constantly be on hand to reapply the foams, so that if that blanket breaks down, we still have that hot metal, that hot steel, or an ignition source, the fire is coming back. It's going to reignite. Where now, if we can sit there and we can cool that steel, eliminate the heat, eliminate that reignition source, if we can encapsulate that fuel, eliminate that fuel, okay, we can have a more of effect of being able to extinguish the fire and keep the fire out without having that need for that blanket. And again, it's going to be dependent on the size of the fire. It's not, a small amount of the encapsulator agent is going to put out a large scale fire. There's formulas and things that, we would have to get in and do additional training with people, help them understand its uses. But when it comes to those small spills, we can have a huge impact at being able to encapsulate those fuels in those small areas, the small scale. But we can work together as I continue on in the program. We'll see how we can work together with other agents to be able to work on some of those larger fires. We look at the encapsulator agents. What makes them so versatile is the fact that they work on all classes of fires. And I bring this up, and it's, while even though this is dealing with petrochemicals, we still have, the Class D metals, we still have lithium ion batteries, and we still have ordinary combustibles that are at many of these facilities, many of these areas that we also need to deal with. So when we talk about the versatility of the encapsulator agent, here it's one agent that works on all these classes of fires. It's no need for multiple extinguishers anymore. And when we get into the lithium ion batteries, we keep hearing copious amounts of water, but when we use water, we're also hearing about days, hours, weeks later, these batteries are reigniting because water is not able to cool, or at least keep them cool to the point where they won't reignite. So there's still a lot of hazards when we sit there and we start looking at lithium ion battery hazards and the encapsulator agents. Testing has started on the encapsulator agents back in 2008. And I believe currently, if we go into the NFPA standards, NFPA 18A is the only standard currently that addresses testing that has been done with extinguishing agents on being able to extinguish lithium ion batteries. And this testing has started back in 2008. And as you can see in here in this annex, it talks about just a few of the reports that were available to us back in 2022 to be able to get into the standard. But, the Kiwa Labs, the DACRA, Daimler, Deutsche Automotive, Bosch, the list is extensive, and many prestigious facilities that have tested it. And it's all been third-party documented testing that has shown that the encapsulator agent is able to stop thermal runaway and extinguish lithium ion batteries. The big thing that everybody is looking for is a product that is eco-friendly. No PFOS and PFOAs, as I mentioned earlier, that we're dealing with currently. And when we start looking and reading about some of the new products that are available, we're finding out that we need to have longer application times because they don't seem, or they don't appear to work as effectively as the fluorinated foams. And the other problem is that the bubbles break down faster, so the reapplication time is even sooner than it was previous. So there's some drawbacks even with some of those others. And when we sit there and we look at the application of the foams, there's usually three application rates or three application techniques. It's rain it down, bank it in, or roll it on. And we talk about an encapsulator agent. There is no, because again, we're not using bubbles, we're using a water droplet. So with the encapsulator agent, it's aggressively and rapidly fight the fires. It changes the way we do things and how we're able to do it. So when we look at how they work, again, I mentioned early on, it reduces the steam. There is no steam. It has an effect on reducing the toxicity and the smoke. By doing so, we're improving the visibility, and it shows here the rapid extinguishment, 20 times less IDLH environments, because we're removing and we're helping to lessen the toxicity and the carcinogens that are in that black smoke. There is no PFOS A's in it, so that fluorinated hazard, those forever chemicals, this has been tested by EPA approved lab for 27 different fluorinated ingredients. The results were there were no detectable amounts of fluorinated ingredients in F500 encapsulator agent. It's non-corrosive, it's biodegradable. It's also, I mentioned earlier, the ability of it to reduce those toxins and carcinogens. And we've got reports showing, up to 98.6%. With cancer being such an issue in the fire service, here again is a huge benefit to making our profession safer. We look at the efficiency. If we're able to have that much effect and being able to cool, okay, we're using much less water, much less time. Okay, there's less environmental damage, there's less wear and tear on equipment, and much more effectively even on the firefighters. Okay, the stress, the fatigue, the number one cause of injuries on the fire ground, we're using and being able to have an effect on. We look at the rapid heat reduction, and again, I'm going to bring up, our refineries, our tank trucks, all these areas in our industrial facilities where, you have a fire, that metal heats up, even though we may be able to put a blanket down and suppress the fire. If we're not there to constantly keep reapplying that foam or whatever we're using, when that blanket breaks out down, exposes the fuel, we have that reignition. So this is where I'm saying, we can be used in conjunction with, you can use the encapsulator agents to cool down, help rapidly extinguish the fires, cool down the steel, and then we can use those foam blankets to keep those and suppress those vapors. So we can use, as it says here, we can be used in combinations with other agents to make the operations and the scene safer. When it comes to the three-dimensional fires, if we go into the NFPA 11 standard, look at Annex A11 of the standard, it's going to show in there that foams are not suitable for three-dimensional flowing liquid fuel fires or for gas fires. So up until this point, we haven't had a solution. So a small little manifold fire, and a case history, a small manifold fire in a tank farm ended up burning up 11 of 15 tanks, where it could have just been held to a manifold. The problem was foam is not suitable for that three-dimensional fire, and that's what was used. So having the proper agent to deal with the types of fires that we're now dealing with is crucial to being able to keep our fires small and controllable, rather than letting them get out of hand and grow. So huge difference. And one of the other advantages of the product is it's safe to use in energized environments with the foams that create the bubbles. It creates basically a bubble-to-bubble interaction. So it's a conduit from the hose stream to wherever it's coming in contact with. And it happens to be something that is energized. The electric current can flow back to the person holding the nozzle. So that is a danger when we're using those. With the encapsulator agent being in the water stream, you're not using a broken stream or a wide fog pattern, and because you're now using the smaller droplets, there's no actual change. So the encapsulator agent in the water is no more conductive than the water, based upon some testing that was done. Here's a video that I want to show. It's an older video that was done in China. I like to show this one because it gives a really good comparison of use of encapsulator agents, F500 and foam. Here we've got a large tank. It's got 574 gallons of diesel fuel in it. We're going to use a 3% solution of the F500, and they're going to use one monitor when they are doing this fire. And I'm going to kind of speed through here just a little bit. So we're going to have it, and as you can see, even though we're using the F500, you see here bottom left, they have a hose stream that's against the side of the tank. That's one of the things that you'll see many times when you're using foam, because what they're trying to do is they're trying to cool the steel tank down so that the foam can begin to form a seal against the side of the tank. Otherwise, if they can't cool the steel, the bubbles are just going to evaporate away because the heat of the steel is going to destroy the foam blanket. So here it's showing the encapsulator agent being used in this tank, and they're able to extinguish this fire with the one monitor, the 574 gallon monitor, in just 58 seconds. It shows, 552 gallons of solution, only 16 and a half gallons of the concentrate. So they now go back, they set up, and they're going to now do foam. And let me speed this up again. And when we start using the AFFF foam, we're getting into 2 nozzles. So we've changed from the 574 gallons per minute to now flowing a rate of 1,140 gallons per minute. You still, again, see them using the water lines on the side of the tank trying to cool so that the foam blanket can, get up close to the tank, create that seal so it can smother and extinguish the fire. So they're going to continue to flow. We're going to speed this up here just a little bit. As they continue to go through, you'll see whiffs of smoke still coming up as they go. Again, trying to hurry this up, but it takes them with the foam 7 minutes and 35 seconds to be able to extinguish it. So it's 865 gallons of the solution, 260 gallons of foam concentrate. Huge difference. So we went from 16 and a half gallons of F500 to 260 gallons of an AFFF. And again, I mentioned when we talk and we start hearing about the green foams requiring an even larger application rate, longer duration, you're looking at even more, and then the reapplication times. So a huge difference. And I show this because many times people will ask, well, how much does it cost? And again, when we sit there and we start looking at the finances of how much does an encapsulator agent cost, and it's not just cost. Let's look at the environmental. Let's look at the amount of water that's needed. Very first, one of the things that I showed was all of that water supply line to be able to supply the water for that, those types of fires. And here's again a great example of how much less water is needed to be able to deal with some of these large scale fires. It makes a huge difference in being able to deal with them. We talk about the the encapsulation of three-dimensional fires and the Veep fires. And we sit there, and again, I mentioned that manifold that burnt down 11 of 15 tanks. Very easily, if encapsulator agent had been used on that manifold, it could have been able to extinguish that three-dimensional fire. And as we can see here, if we go into NFPA 18A again, and we go into section 12 of the standard, it's covers about design guidelines. We'll see in there how it talks about this vapor explosion encapsulation protection system, how it's able to encapsulate these vapors, these gases, how it's able to have an effect in cooling the steels. And we can control and we can prevent many of these large fires from happening by keeping them small or preventing them from occurring altogether. Especially, like say, you start dealing with these natural gas or LP gas and some of the other things, the vapors that are present at our refineries, or even when we're loading and offloading tanker trucks. We look at the spills and how we're able to deal with those. And we'll get into the spills and the vapor control here and how it works, how it's able to neutralize. And unlike with foam, which needs to create that blanket, how we're going to work on it that different, how we're able to neutralize it, how we're able to, once we've encapsulated it, reduce the hazard and even the cleanup. Because now in many areas of well, here in the United States, I know many states are allowing, once we've encapsulated that gasoline, your cleanup is let it evaporate away. There's no need for a cleanup contractor to come in. We start looking at the fluorinated foams that are still in use in some areas in the events of emergencies. And many of the states are treating those almost like a hazmat incident. If you use the fluorinated foams, it has to be documented. You need to get a cleanup contractor in there to mitigate those scenes. The expenses are growing. And as we know now, we hear on the news, lawsuits for many applications and where uses are contaminating areas. We're starting to see lawsuits being brought to the courts, and people are having to pay for these cleanups. So it's a huge issue when we start looking at the hazards that it brings in comparison with other agents that are on the market. So the benefits, because in many instances, we start getting some of the refineries that are close to, let's say, the Gulf here in the United States, or, some of the waterways, which may be salt or brackish type water. You don't need fresh water with encapsulator agents. So some of the benefits are it is very effective yet when mixed with salt water on the petrochemicals. When we look at the local regulations, as I said earlier, once we've encapsulated those fuels, those oils, those spills, the cleanup is allow it to evaporate away. But that ability for this on those small spills, to be able to neutralize those small spills, be able to get your monitoring equipment and monitor, making sure that the LELs are down to zero. Once we've got those LELs down to zero, there's no longer a flammable hazard. It's no longer an ignition hazard. As we can see here from this video, here's a spill that was on the ground. The encapsulator agent F500 is used on the one side. It's encapsulated the fuel. It's neutralized it. We've started the other half that wasn't treated, and you'll see that the flames do not cross over to the other half that was pre-treated. They come along, they're going to now extinguish the fire. Once they extinguish the fire, they're going to give just a little bit extra, just to make certain that all the fuel is encapsulated. As I said, there is a formula. It's 1 part of F500, 8 parts of fuel, 40 parts of water, and kinetic energy. So here, as you see, the kinetic energy would be the water splashing against the ground. There's no blanket, so as you see here in a second, he's going to stop, sweep his foot across the surface. There's no blanket to break. Once that gasoline is encapsulated, it is no longer a hazard. As I said, cleanup, nothing special. Just let it evaporate away. There'll be no trace that there is a fuel spill there. So there's no special cleanup that's required. We look at some of the other areas when we talk about the petrochemical, having to clean, having to gas tanks for inspection or maintenance work. These, in many cases, can take days to be able to clean and degas tanks. So we'll see how with the encapsulator agent, we're able to have a huge impact in changing the time required to be able to clean these tanks up, be able to minimize the hazardous vapors, allowing for a quicker entry into these, and just the overall difference in the amount of time, the amount of manpower it takes in order to deal with the tank degassing. So we look at it, the safety that's involved for the workers is again a huge issue, because we're sending them into environments that are not necessarily safe, and we'll go over some of the current ways that they're doing it. But looking at it, we're going to see how with the use of the encapsulator agent, we're going to reduce the overall cost of the cleaning, reduce the downtime by 60% or more. Those cleaning costs, excuse me, the environmental impact again is huge. And then the H2S, which is a hazard whenever we're dealing with petroleum products, how we're able to have an effect and eliminate those H2S. So this comes to us, this is a case history again from the Trinidad and Tobago that deals with some tank cleaning. And they're going to talk about the contamination, how these microorganisms can grow in certain types of fuel, and so for that reason, they have to get in there, and we have to clean these out and get these bugs that they call the diesel bugs and the funguses out of these tanks, so that they don't continue to contaminate fuels or cause problems. So they have to drain the tanks, and they have to then clean them out. And when we sit there, we start looking at, getting it done, the treatment, how we sit there and how we make that scene safe, and doing it, the removal, we have to be able to get the fuels out, do that transfer. And as it goes through, they talk about, the above ground storage tanks, the vapors, the flammable liquids, all the VOCs, the LELs, need to be brought down to a level that's safe before people can start making entry into these tanks. And when we sit there and we look, what used to take hours and hours and hours, they're now being able to achieve in rather quick time. And it talks about, the things that they're hydrojet to clean in these above ground storage tanks. So it's showing some pictures of the sludge and the things that they're removing from these tanks. And the cleaning, they're talking about the post pictures. You can see from the previous picture all the dirt and the sludge that was there, and now how much cleaner the tanks looks, and the difference. We get into the tank degassing, and when we sit there and look at this one, they're talking about the nitrogen that's being used when they degas a tank. Here you have a tank that's 1 million liters. They're using nitrogen. They're showing a 12-hour downtime, the treatment for 6 hours, and 6 hours for ventilation. So what they're looking at is, before they can sit there and start making entry, they're using nitrogen to push the flammable vapors out, which they're then using and burning off for 4 to 6 hours. After they burn off for 4 to 6 hours, then they open up a door towards the base of the tank, and they start checking the LELs. If the LELs are still high, they continue with the nitrogen until they drop down the LELs to a permissible level. And once they have gotten those LELs down to a permissible level, then they leave that tank door open to let it ventilate naturally, as it shows, for about 2 hours. After that, then they sit there and they start bringing in some mechanical compressed air systems, and they start to mechanically start to ventilate the remaining time. So we're looking at a large amount of time to be able to get to that. We're looking at 14 hours to get to a point where we can finally start to get some people into working on the tank. When F500 was used in degassing, here we're showing that they were 60 liters of F500 in 20 minutes. No ventilation was required. The ability to encapsulate those vapors, those flammable vapors that we've been talking about, is huge, as you can see here. In 20 minutes, a 1 million liter above ground storage tank was degassed with no ventilation required. And it shows the way they did it. It was a 3% solution of the F500 towards the bottom of the tank, using a fog pattern, 30 to 60 degree pattern, for about 20 minutes, measuring that LEL at the door's entrance, and watching and making sure that they get that LEL down, and again, verify it's at zero before anything or anyone starts making entry to do inspections in the tank. And then when they get done, anything that's remaining at the bottom of the tank, as they've been encapsulating the vapors, they're also then encapsulating fuels. So that tank now is ready to be cleaned and inspected. So we look at the cost of labor, the cost of cleaning, the downtime, the amount of personnel that are on scene. When we looked at use of nitrogen, it was 14 hours versus 20 minutes. The safety margin, you have, when you're using the nitrogen and then you're venting it, again, you're constantly monitoring for those LELs, making sure that they're safe. And when we're using that encapsulator agent, yes, we're also monitoring the LELs, but we're encapsulating those flammable vapors and making things much safer, and being able to clean and degas that tank. So we're minimizing the downtime. We're getting that tank cleaned and back in service quicker. So when you have, or you're in the process of changing one product from the tank to another product, you need to be able to turn that tank over quickly. Rather than taking a day or two to be able to start to use that tank again, you're able to do it in a much faster time, which makes, again, the use of that tank and the productivity faster. So when we sit there and look at different methods, some of the equipment for using the encapsulator agent, we have multiple applications. We have the fixed wheel units, 2.5 gallon fire extinguishers, piercing rods, quick attack mobile units, which are in the 25, 50 up to 100 liters, portable carts, response trailers, specialized equipment for the tank degassing. But when we sit there and we start looking at the fire protection, we talked about, the water supplies and being able to get the agent into the water. What we use is the Diamond Doser by FireMix, which is a water-driven proportioner. It's very reliable, easy to use, and it helps being able to get the agent into the water stream through a wide range of flow rates at a constant percentage. So it's a very, very effective way to add the agent into water streams and being able to deal with these emergencies, and being able to handle all of the different problems. One of the nice things are, there's no additional power requirements as far as, engines or electricity to being able to make or help the systems operate and run. Your concentrate tanks, the larger capacity, so that, again, we can keep that more accurate dosage. Minimal maintenance, so it's easy to refill as it's going, and it's more cost effective, and being able to use. Just a quick video to show. when we sit there and we, talk about the F500 as well, like I say, we do consulting, and we do like our hazard analysis, fire protection assessments, emergency response planning. We want to make certain that we're not just going out and selling a product, but we want to make certain that it's being used correctly, proper percentages, and help out in every way we can in making certain that we're meeting your needs and applications that you're looking to protect, and how we're able to help in getting this product into your facilities. So we look at the training. Another huge part of the product is being able to apply it correctly, the right percentages, being able to mitigate the hazards and the emergency response. With the training, we also provide subject matter experts to help out in instances that may require some help in helping to deal with these emergencies. So we want to make certain that your people, if they're going to use, because in the past they had a foam knowledge, encapsulator agents, as I said, we do not work by making bubbles. We work by chemically changing water droplets. So because of that, we want to make certain that we train people to understand the difference and being effective at being able to utilize the product in dealing with all of these different hazards that we have gone through here today. So the training is crucial in making certain that we have people trained in using the product correctly. Well, I want to thank everybody for participating today. I know for some it's early in the morning or later in the evening, but thank you for taking time out of your day to join us today. I hope you found the presentation informative, answering some questions and giving you some ideas of the benefits and the abilities of an encapsulator agent being able to deal with a wide range of hazards rather than just specific. But the whole thing is as I started out, when I mentioned retiring, trying to work to make firefighting a safer profession, not only for firefighters, but employees of facilities, and petroleum facilities, as well as, all of the different areas around the world where we have firefighters that are being affected on a daily basis with some of these. So with that, I'm hoping to educate and bring the message across that, we have an agent that is very effective, environmentally friendly, and makes some of these high hazard fires a little bit easier to extinguish and deal with. We can sit there and we can keep the fire small rather than having it grow into something that's large and unmanageable. So with that, I want to thank you. I appreciate your time. Thank you very much. God bless and have a great day wherever you may be. Thank you.